If you're watching this video, hopefully you've already seen the video about matrix addition and subtraction, and hopefully you've seen that adding and subtracting matrices isn't really so bad as long as you just think about going position by position. Matrix multiplication, by contrast, is a little bit more complicated, and in this video, we're going to try and figure out how it works. To start, you can see that I have an example problem here, in which we are going to multiply this matrix on the left by this matrix on the right. You'll notice I haven't put any kind of a symbol in between these two matrices, and that's because just like with numbers and variables, if there's no symbol, multiplication is implied. So we are multiplying these two matrices here. Now, we should first think about what the result of this is going to actually be. When we added two matrices, the result was a matrix. And indeed, in this case, when you multiply two matrices, you're also going to get a matrix back. But what's it going to look like? You can see that right now, we're multiplying a 2 by 3 matrix times a 3 by 2 matrix. In other words, these two parents look very different, and it's sort of not clear, maybe at first, what their offspring should look like. Here's how you can tell. When you multiply two matrices together, the result will have the same number of rows as the matrix on the left, and it'll have the same number of columns as the matrix on the right. So our result will be smaller than its parents. Our result is going to be a 2 by 2 matrix, which is a little bit strange. Buckle your seatbelts, because now we're going to talk about how you actually get the 4 individual numbers that go inside of here. Here's how we do it. We know, because you've watched the last video, that we can think about the 4 things that are going to go in this matrix in terms of their position. So for example, the number that goes here is going to be in the first row and in the second column. Likewise, this element is in the first row, first column. So let's just take a quick peek at how we obtain these elements. We're going to start by trying to get the element that belongs in the first row, first column. How do we get that number? Well, here's how we do it. We are going to get it by looking at the first row of the first matrix and the first column of the second matrix. Just pause for a second. Let's jot down some notes here. Let's jot down some notes here. The thing that we're trying to get is in position first row, first column. So we are using the first row and the first column of the first and second matrices respectively. What are we going to do with these things? Well, we're going to take the first row and we're sort of going to multiply it by that first column that I highlighted. Here's how that multiplication process works. I'm going to take the first thing in the row and multiply it by the first thing in the column. So my scratch work down below is going to look like 2 times 3. Now I'm going to move to the next object. So the next number in the first row is a 1, and the next number in the first column is a 0. So now I have to do 1 times 0, and I'm going to be adding up all these products. I keep on doing this until I run out of space. So I can continue to another element here in the first row. The next number is -1. And in the column, the next number is 2. So I need to add the product of -1 times 2. Now I have this sort of arithmetic problem here, which will simplify down to give me one single number. Let's simplify it. 2 times 3 is 6. 1 times 0 is 0. And -1 times 2 is -2. And we're adding these things together. So what is 6 plus 0 plus -2? That's 4. And folks, if you can believe it, 4 is the number that we write there. I didn't say this was easy. let's keep going. We still have 3 more numbers to fill in our 2 by 2 matrix. That is our answer. I'm going to erase my scratch work so we can start again here. And let's change colors so we can keep track of what we've done. Now I'm going to work on figuring out what number goes in the second row, first column of my answer. To figure this out, I need to use the elements in the second row and the first column of my 2 matrices that I'm multiplying. And just like before, I'm going to basically do some multiplying and some adding to get the one single number that I put into this matrix up here. So here we go. My first number in the row is a 3, and I'm going to multiply that by the first thing in this column, which is also a 3. So I have 3 times 3. Now we're going to add something else. What do I add? I'll take the second thing in the row and multiply it by the second thing in the column. So 0 times 0. And then I proceed to the last thing, 4 times 2. All right, simplifying this, I have 9 plus 0 plus 8. So that's 9 plus 8, which is 17. And 17 is what goes in the second row, first column of my answer matrix. We still have 2 more calculations to complete, but hopefully you're starting to see the pattern here. The pattern, once you get used to it, isn't really so bad. You're going to do the same exact pattern for all matrix multiplication problems, which probably comes as a relief. We're going to switch to green and go to our next position, which is going to be here in the first row and the second, column. So to fill in the first row, second column, I need to look at the first row and the second column of my first and second matrices, respectively. Same idea, I'm going to just multiply the first things together and then add some other products. So my first thing is a 2 in this row, and my first thing in this column is a 1. So my scratch work in green is 2 times 1. Now I'm going to add, and I'm going to add in particular 1 times 5. Again, we're moving right in the row and down in the column, so plus 1 times 5. And last of all, we have -1 times -1. Okay, so -1 times -1. So what do we have here? We have 2 and 5 and 1, and adding those things together, I have 8, which is the number that goes there. Let me just erase some scratch work before we calculate the last term that goes into our answer matrix. And let me find a new color here. Perhaps I should use a brown. To figure out what goes into our last spot here, we've got to think about what its coordinates are. It is in the second row and second column. So I need to use the second row, and I need to use the second column. And I'm going to move along just as in the past. Our first multiplication problem is 3 times 1. We're going to add to that the product of 0 with 5. And to that, we'll add the product of 4 with -1. Simplifying this, again, this is sort of scratch work off to the side. I have 3, 0, and -4. Adding all those things up gives me -1. And that's what I put here. So, as you can see, matrix multiplication takes a significant amount more work than simply adding or subtracting matrices. Right now, I'm just going to write below a cleaned up version of this problem. What we just figured out is that 2 times 1 times is that the matrix 2, 1, negative 1, 3, 0, 4 times the next matrix, we did some calculations and we figured out that the answer to this problem was 4, 17, 8, negative 1, that 2 by 2 matrix right there containing those numbers. Okay, so probably wouldn't hurt to see example of a matrix multiplication problem. You can see that this time we're going to multiply a 2 by 2 matrix times another 2 by 2 matrix. And remembering the previous example, we know that our answer is going to be 2 by 2. So let me just draw some space here for our answer, and let's talk about how we're going to obtain it. We're going to go through this example a little bit more quickly, and I'm actually going to write my work straight into the matrix that we're calculating here. So we're first going to work to try to figure out what goes in the first row, first column of our answer. Remembering last time, we know that we need to take the first row and the first column, respectively, of our two matrices that we are combining. Now, into this matrix, I'm going to write my scratch work. So remembering how this works, I'm going to do 3 times 4 plus 2 times 1. We'll simplify later. Now let's work on the next position. Perhaps we should look at the second row, first column. To do that, I need to multiply the second row times the first column. Scratch work is going to go right into my answer matrix here. So I have 1 times 4 plus negative 3 times 1. Let's move on to the next position. If I want to figure out what goes in the first row, second column of my answer, I need to use the first row and the second column here of our two matrices that we are multiplying together. And just remembering how this works, taking the first elements and the second elements and multiplying them together, I have 3 times 0 plus 2 times 1. Last but not least, let's do a quick calculation to figure out what should go in our last spot, down here in the second row, second column. We need to use the second row and the second column, respectively, of our two matrices that we are multiplying together. So I should have 1 times 0 plus negative 3 times 1. And that completes my matrix. So in the same color green as before, I think, we're going to close off this matrix here. And now I can maybe do my simplification. So we're doing this process in a slightly different order than last time, but it's the same basic idea here. We're just simplifying our work at the end rather than bit by bit. So what does my first row, first column turn into? Well, 3 times 4 is 12, plus 2, that's 14. My second row, first column, I have 4 minus 3, which is 1. In my first row, second column, I have 0 plus 2, which is 2. And in my second row, second column, I have 0 plus negative 3, which is negative 3. So there we go. A little bit quicker, partially because these matrices were smaller. There are some matrices that you just simply cannot multiply together. This matrix is 2 by 1, and this matrix is 2 by 3. And if you look at these two numbers, the number of columns and the number of rows of our first and second matrices, those numbers are not equal, and therefore this problem actually